Year 3, it's Miss Her here, and today I'm going to go over your maths activity. Now, I've selected an activity a little bit later on in the lesson, so make sure you watch the video first because it's about ordering fractions, but it's using your knowledge of fractions with the denominator and the numerator and also comparing fractions. So over the last few days, we've established that when you think about a fraction, so I've written 1/3 here. We've got the numerator and the denominator. Now the denominator tells you how many parts something is broken into, and the numerator is telling you how many parts you're looking at. So how many of those 3 parts you're looking at. And it's the same with a half. Now I've chosen these two because there is a common misconception, which means a common and marvellous mistake, that people normally say 3 is bigger than 2. So therefore 1/3 is going to be more than 1/2. But those beady-eyed people out there might also remember that when we talk about a fraction, it's about how many parts we've broken something into. So I'm going to just draw 2 bars underneath each other so that you can see very clearly when I think about a third, I'm going to turn this one into a third and a half, you can very clearly see that 1/3 is in fact a smaller part than half because it's not about the size of the number anymore. That is telling us how many parts something is broken up into. So actually, the bigger the denominator, the smaller the fraction, because you've got to break all those parts out. If I put a denominator of 12 in there, those parts are going to be teeny tiny. But there's been a slight twist on your activity, because although we've got this, a little bit further down your lesson, we've got some with a denominator and a numerator, but also a denominator with more than one numerator, and the denominators are different. Whoa! Now that is some tricky maths. But it says here, so Tommy and Dora are ordering these fractions, and it says, I cannot order these fractions because the numerators and denominators are different. But Dora's saying, well, I think I can use equivalent fractions to help me. Who do you agree with? Now, it says talk about it with a partner. I'm going to be your talk partner today, I hope that's okay. Now let's have a little explore. Now I'm not going to do this one here because this is your activity. I've chosen my own 3 numbers over here. We've got 2 quarters, 8 twelfths, 1/3 and 2 twelfths. Now if we look, now maths is all about spotting patterns, and if we look at the denominators of 4, so ignore the numerators, they're not relevant at the moment, just look at these numbers along the bottom, 4, 12 and 3. What pattern do you notice? Why have I chosen those denominators? Well, if you think, they're all multiples of each other. How many 4s go into 12? 3. And how many 3s go into 12? 4. How many 12s go into 12? 1. So they're all multiples. All 4 and 3 and 12 all go into 12. This is going to be a big clue. So although the denominators are different, we can now use our knowledge of fractions to have a go at making them have the same denominator. And watch, it's going to be like a bit of magic. So here, I've got 12ths here. So before we do any ordering, any comparing, we need to make sure that all these denominators are the same size. It makes it easier for us to then order and compare fractions. So we can need to turn these 2 fractions, these two denominators, into 12ths. Because 12, we've established, is the biggest multiple. So let's have a look at 4. Let's have a look at our quarters. So 2 quarters. Now we need to turn it into 12ths. Now how many quarters, how many 4s go into 12? What do you need to multiply 4 by to get to 12? Well, if I write down my 4 times table, 4, 8, 12. 1, 2, 3. So it goes in there 3 times. And as I've mentioned before, what you do to the denominator, you have to do to the numerator. So what do you need to multiply 2 by to make sure that it's an equivalent fraction? You need to multiply it by 3 as well. So 2 times 3 is 6. And actually, those savvy-eyed people out there might have noticed that 2 quarters is equivalent to half, and 6/12 is equivalent to half. Because if you look at the numerator and the denominator, there's a bit of a pattern. So now that we've converted 2/4 into 6/12, I'm just going to rub this bit out so that you can, I'll write it out underneath. So it was 6/12. I'm now going to look at my thirds. Now I wonder if anyone knows what I need to do. So I've got 1/3, how am I going to turn it into 12 so they are all equivalent, they all have the same denominator? Well, I need to think about what I need to multiply 3 by to get to 12. So how many 3's go into 12? Now, top tip here, I'm going to write my 3 times table. 3, 6, 9, 12. 1, 2, 3, 4. So I need to multiply 3 by 4 to get to 12. And what I do to the bottom, I have to do to the top. So what am I going to do over here, year 3? I'm going to need to multiply it by 4. So 1 times 4 is 4. So 1/3 is actually the same as 4/12. So coming back to this question over here, Tommy says, I cannot order these fractions because the numerators and denominators are different. And Dora is saying, well, I think I can use equivalent fractions to help me. What we've done here is we've actually converted these fractions into their equivalences, which means to make sure that they've all got the same denominator. And now if you look, 6/12, 8/12, 4/12 and 2/12, can I now order these fractions? Yeah. Which is the smallest 12th that I've got here? Well, I've got 2/12 at the end, so 2/12 first. I'm going to cross it off when I've used it. What's next? We've got 4/12 next. Now, I'm actually going to look at my original one, so I'm going to write 4/12 here. And cross it off. What comes next? We've got 6/12. Just there. And then the last one, 8/12. So you can in fact order fractions, you just need to make sure that you convert the denominators so that they are all the same. So if you look at your activity, you've got a 5th, a 15th, a 3rd and a 15th. These numbers have been selected for a reason. And if you look really carefully at these two numbers, how do they link to 15? There's a question for you. I'm going to let you have a go at this challenge. Let me know what you find out, and if you really want to challenge yourself today, see if you can actually order these fractions from smallest to biggest to prove your answer, to decide if you agree with Tommy or Dora. Well, have a lovely day, Year 3s. Enjoy fractions, and I'll catch you for another how-to video. Bye-bye.